Hydrogenation means addition of hydrogen. So when benzene hydrogenation is done, it will convert into cyclohexane because all of the alternate double bond or vibratory double bond will break, which result in a formation of a cyclic alkane. So nickel is used as a catalyst about 200 degrees centigrade and 300 atm, and the reaction is addition and reduction. Addition because only one product is there, and the term reduction means addition of hydrogen means reduction. Then acylation. Acylation means when we add an acyl group, we call acylation. What is acyl group? Like C double bonded with O, an alkyl group is known as acyl group. So also it's a Friedel and Kraft reaction. The main thing is the production of electrophile. So how we produce an electrophile? The similar way we produce an electrophile, we have AlCl3. If we have acyl chloride example CH3, C double bonded with O and Cl. So what happens, this chloride ion will take both of the electron and attract it towards aluminum chloride. It will form AlCl4 with a charge -1, and it will form acyl C double bonded with an alkyl group with a charge plus. And this charge plus is attracted towards the benzene and form a bond with benzene. Then hydrogen will break a bond and the ring will close. And what will be the name of the compound? How to identify the name of this compound? So it's a phenyl and ketone. The term phenyl, because if it's a benzene ring, we call that as phenyl. And if we consider benzene ring as a substituent group, then we call that as phenyl. So phenyl ketone is produced, and so benzene in acyl chloride is added in the presence of aluminum chloride, which is as a catalyst, because the later hydrogen attracted towards aluminum chloride, it will form AlCl3 plus HCl. We should heat under reflux about 50 degrees centigrade, and the reaction is electrophilic substitution reaction. So you can see here it's a same way the reaction occur that was happening when halogen alkane were reacting, and alkylation. This is acylation because acyl group is added, alkylation when only alkyl group is added. So the reaction conditions, you have to learn how electrophile is produced, and then what will be the overall equation. This is a reaction mechanism, but the mechanism is same. So one time you learn the mechanism, journal mechanism for electrophilic substitution, all are the same reactions. Any doubt in this?
No.
Now, what are the effects of these side groups? Some of the groups increase the reactivity of the benzene, and some of the groups reduce or decrease the reactivity of the benzene ring. Benzene ring itself is not much reactive. Its reaction even started from 45 degrees centigrade to 60. So at room temperature is not reactive. But how the different groups, attachment of a different group affects the reactions of the benzene. So effect of the side, because if there is an electron releasing side group is there, electron releasing side group means the group which tend to give electron to the benzene ring, such as alkyl groups, phenol or alcohol or amine, they release electron in the delocalized and make a higher electron density. So more attracted towards electrophile, therefore carry out substitution reaction more readily with normal or milder condition. Like if you have a benzene ring, and in this benzene ring, if you have OH attached and there's another benzene ring without OH. So a benzene ring with OH is likely to be more reactive as compared to benzene ring without OH. What is the reason for that? Because this is having lone pairs. So this lone pair, OH is having lone pair. So what they do, they increase the amount of electron or make the electron density higher for a benzene. So as they make the, like, because the pi electrons are there or delocalized electron system, and already there are lone pairs. So due to these lone pair, what will happen? So electron releasing groups, they increase the density of a benzene ring. As the density of benzene ring or electron density of benzene ring increases, the electrophiles can be attracted easily towards the benzene ring. So effect of delocalization on the side groups with lone pair. So if OH is there or chlorine atom is there or NH2 group is there, if they're directly attached to benzene, nitrogen, oxygen and chlorine, they contain a lone pair. Chlorine is having 6 lone pair, oxygen is having 2 lone pairs, when nitrogen is having 1 lone pair. So due to these lone pairs, the electron density of a benzene increases, so it is likely to react. So when these groups are attached to a benzene ring, the delocalization of a benzene ring will extend to include the lone pair as well, and this changes the properties and the reactions of the side group. So in this example, like carbon and chlorine bond is there in a chlorobenzene, is made stronger, and typically halogen alkane substitution or elimination reaction do not occur. Also, the electron-rich benzene ring will repel the nucleophiles. And the delocalization makes the CO bond stronger, carbon bond, and then OH bonds weaker. And the phenol do not act like alcohol. It is more acidic and does not oxidize. Because what happened, the bond between carbon and oxygen is stronger now due to the presence of the lone pair and the electron rich side, and the bond between the carbon and hydrogen is weaker. So as this bond is weaker, this bond can break easily, and if this bond can break easily, the phenol can lose its OH. So if it can lose its OH, it will become acidic. Same thing, phenylamine, they are less basic than aliphatic amine. Aliphatic amine means, like, if you have CH3, CH2, CH2 and NH2. This is called aliphatic amine. Aliphatic amine, why they are basic? When the substance we call a basic, it means it has a tendency to accept proton. Because of these lone pair, it can accept proton. But what happened, the lone pair of amine group which is attached to benzene ring, because these lone pair are also used in the system of delocalized electron system of a benzene ring. So these lone pair now does not have a tendency to attract the proton easily, as they are not having a tendency to attract a proton easily. So they are less basic. They are basic, but they are less basic or weak basic as compared to aliphatic amines. Is it clear? Any doubt in this?
No.
So copy this part. And actually the full part is important, so let you copy the whole. Then the phenol group, when a benzene ring, we have a substituent group OH, we call that as a phenol. So in a phenol, the OH group is directly attached to a benzene, and that solutions are acidic. Why the solution of phenol are acidic? Because the bond between carbon and oxygen is stronger, so it can lose its hydrogen, which make it acidic. So in a phenol, a lone pair of electron is there on oxygen. Lone pair of electrons are there, and that could so increase the electron density of arene or a benzene ring. So phenols are very weakly acidic. The solutions are acidic solutions. And why they are weakly, but they are weaker acids than carboxylic. Even if you have a carboxylic group, carboxylic groups are stronger acid as compared to that of phenol. Both phenol and carboxylic acid will react with sodium metal, but when acid react with metal, it will give salt and hydrogen. So they are weaker acidic. So both phenol and carboxylic acid will react with sodium metal and sodium hydroxide, because so only carboxylic acid will react with sodium carbonate, as the phenols are not strong enough as an acid to react. So when we add a sodium metal, so sodium will displace this hydrogen, it will form ONA, and then hydrogen gas is given out. When sodium hydroxide is there, the same thing, it will form ONA plus H2O. But with carbonate, sodium carbonate, carboxylic acid can react, but phenols cannot react. So sodium phenoxide compound is more soluble than original phenol. So a solid phenol dissolve on addition of sodium hydroxide. Is it clear? This is about the phenols.
Yeah.
The last part for today's class is reaction of a phenol with bromine. So, and these reactions can occur in a room temperature. Why the reaction can occur in a room temperature, as we discussed earlier? Because these OH groups are electron releasing groups, so they increase the electron density of the benzene ring, so make it more higher electron density, so it can attract the electrophile easily. So in this case, we don't need the halogen carrier or a catalyst to produce an electrophile, because what happened, as the lone pair of oxygen is having a lone pair, and there are electron pairs, the pi electron pairs in a benzene ring. So these electron pairs will repel the bond between the bromine. So due to this repulsion, one will get a negative charge, positive, another one will get negative. So electrophile can be produced because of high electron density. So we don't need like iron 3 bromide or aluminum trichloride. The reaction can occur at a room temperature, and we observe a multiple substitution reaction occur. So in phenol, the lone pair electron of the oxygen pi orbital and partially delocalize into a ring, and electron density increases, which make bromine molecule polar. So phenols are used in a production of plastics, antiseptics, disinfectants, and resins of paint for paint. And the product is 2,4,6 tribromo phenol. It is a white solid. You have to learn this appearance. Why? Because 1, 2, 3, 4, 5, and 6. So second position, fourth position, and sixth position, we have bromine. That's why we call that as tribromo phenol. Is it clear?
Yeah.
Okay. So this is the last topic of today's class. I will end the session and share the recording with you.